Hello everyone, I'm Kaushalya and I'm from Hyderabad. I'm here to teach chemistry. So we are going to discuss about atomic structure today. So here we will discuss what exactly an atom is, what exactly atomic structure is, what happens with it. So moving on, what is an atom? An atom is the smallest particle of an element which can or cannot exist, but this smallest particle involves in a chemical reaction. So it says that an atom can or cannot exist. So what happens? If an atom is involved in a chemical reaction, at that time the atom combines with the other atom and will not undergo any reaction. Instead, they remain the same. Instead, they remain the same and they rearrange. And what happens if an atom cannot exist? It combines with another. It combines with another small atom. What makes an atom? What makes an atom? People say that never trust an atom that makes up everything. Yes, true. Atom makes everything on the universe, right from an apple, right from a metal to a grain of sand. We never know what is there exactly, how small any element or how small anything is. When we look deep into it, we come to know that it's all made up of an atom. So explaining about atoms means all it started all it started with the law of chemical combination. So John Dalton was the person who discovered atom, who worked on the atomic structure, who supported law of chemical combination. So John Dalton was the person who introduced the Dalton atomic theory. So his theory came up with different postulates. So here are a few postulates of his atomic theory. Um, so the first postulate of his theory is all matters made up of tiny particle is called an atom, which participate in a chemical reaction. Exactly. We will see how this works. So he's trying to say, like, yes, he's trying to say if any atom, one single atom, combines with other atom, gives you a combination. So this is where a chemical reaction occurred between two tiny atoms. So this is one tiny atom and this is the other tiny atom. A chemical reaction. It means these two atoms involved themselves with the chemical reaction and formed an atom. So this is the atom. Coming to the next postulate, atoms are indivisible particles. They can neither be created nor be destroyed in a chemical reaction. Yes, true. When we see this copper sulfate, when combining with sodium carbonate, give us copper carbonate plus sodium sulfate. So the atoms didn't split, they didn't divide themselves. Instead, they started rearranging. That is what is mentioned That is what is mentioned in this. You can see, so that is what is mentioned in the star quoted, that atoms do not form a new atom, instead they rearrange. So when we look into this, the atom didn't divide itself. Instead, it rearranged. Here we can see the copper rearranged itself with carbonate here. It didn't divide itself with anything else. Instead, it rearranged themselves. So, coming to the third postulate, atoms with the same element are identical in mass and chemical properties. Again, we can have the same example. Imagine if copper is of 5 grams, it will be same here with 5 grams. There won't be any changes. In the same way, atoms of different elements will have a different mass and chemical properties. Coming to the last postulate, coming to the last postulate, ratio combination of atoms is always a whole number. No half atoms are involved. So, what exactly he's trying to say? Imagine a water molecule, H2O, is having two hydrogens and one oxygen. So, this will give a whole number. And again, we can see that no half atoms are involved. So, taking the same water molecule, a 2.5 atom or a half atom cannot give us a whole number. So these are the postulates explained by John Dalton. Moving on to the next slide. Apart from John Dalton's atomic theory, apart from Dalton's atomic model, there were other scientists who came up with different atomic models. Out of them, the three are atomic model, Bohr's atomic model, and Thomson's atomic model, and Rutherford's atomic model. And Rutherford's atomic. This is Bohr's atomic model, showing a nucleus surrounded with an atom, and this is Thomson atomic model, which resembles with plum pudding model. It is an example of a plum pudding model. This model resembles with watermelon. So we see that the seeds are embedded in the melon. So this is how he was trying to explain. This is how he tried to put his atomic model. So so in his model, he was trying to tell that the negatively charged electrons are embedded within the positively charged matter. So the plus symbol are the positively charged electrons, and the signs representing a minus are negatively charged electron. So these were resembling with watermelon. And coming to the Rutherford's model, he took a gold foil to explain his experiment. He was trying to tell, so in his model, we can see the negatively charged electrons were surrounded with nucleus of atom. So moving on. So we were talking about what an atom is made up of. Atom is basically made up of three basic particles or subatomic particles, and those are protons, neutrons, and electron. Here raises a question: do these particles have any charge? Yes. The protons in an atom are positively charged, and neutrons do not carry any charge and they are neutral. So they are neutral. And the electrons are negatively charged. What exactly happens with an atom? So in an atom, proton and neutrons reside completely in a nucleus. They both together reside in a nucleus. And surrounding these nucleus, we have electrons. So electrons surround the nucleus with specific energy of shells or orbit. So the electrons on the outermost shells are called as valence electrons, and that particular shell is called valence shell. So how many orbitals, how many shells support these electrons? How many electrons do we have? So we have K, L, M, and N shells. So it's very simple. So we see in a solar system, planets revolve around the sun. Here we can see it. Here we can see it. The planets revolve around the sun. In the same way, we have electrons. Same way, we have electrons on the outermost shell or on the outermost orbits. So here we can see the K, L, M, and N shells. This is the first shell, this is the second shell, this is the third shell, this is the fourth shell. So we also have a formula to see how many electrons are, are present in a shell. So the formula to calculate how many electrons are present in shell is 2n square. So this is the formula. 2n square is the formula. So n is the number of shells. Sorry, n is the number of electrons present in any shell. So we will be having 2 electrons in K shell. We will be having 1 electron in the K shell, 2 electrons in L shell, M electrons in N shell, 3 electrons in M shell, and 4 electrons in N shell. Hence, we'll be having 2 electrons in K shell, total number of electrons in each shell. So K shell will hold 2 electrons, N shell will hold 8 electrons, M shell will hold 18 electrons and N shell will hold 32 electrons. I will clean up this. So here arises the question, how do atoms look inside? Till now we spoke what happens in an atom, what happens in an atom, what is an atom. Now we will see how atoms look. Can we really see them? We spoke that though atoms are very smallest particle, how small they are. Can we see them? So atoms are spherical in shape. Atoms are spherical in shape. They are not cylindrical. They are not oval. They are not rectangular. Atoms are only and only spherical in shapes. So how to know the size of an atom? So size of an atom we can measure with atomic radii or radius. We just take the circumference of any circle. In the same way, we have the nucleus and the outermost shell. So to get the size of the atom or to know the atomic radii or radius of an atom, we have to calculate the distance between the nucleus and the outermost shell of an atom. So that is how we get it. And we have a specific unit to calculate its size, that is nanometers. As we have a question, can we look them? Can we see them? No, we cannot see them with our naked eyes, not even with a conventional microscope. We can see how tiny an E. coli, or how tiny a bacteria, how tiny a virus is. But we cannot see how tiny an atom is with a conventional microscope, neither with our naked eyes. Scientists brought up scanning tunneling microscope. Yes, scanning tunneling microscope, the STM, helps us to look into the atom under this microscope. So here we can see this is a silicon, this is the silicon. So these are the atoms present in a silicon element. So the ones rounded with the ones encircled with a white marker, this is how an atom looks in a silicon element. And coming to next, how to measure them, we have atomic number. We have atomic number set up for each and every element. How to find them? So atomic number, just we have to check number of electrons or number of protons present in any atom of an element. It's called atomic number, and it is denoted with the letter Z. The same way, what is the mass? What is the mass of an atomic atom? So just we have to sum up the protons and neutrons present in an atom of an element. It's called atomic mass, and it is also denoted with capital A. So here we have an example of chlorine. Chlorine. So this chlorine. So this is the atomic number of chlorine, and this is the atomic mass of the chlorine. This is how we can calculate our atomic number and atomic mass. And this is about atomic structure, how they look, and what happens in an atom, what are the atomic numbers, how to see them, how to calculate the atomic number, how to calculate the atomic mass. So this is it about atomic structure. Thank you.